Hey there, math scholars. Mrs. Harp coming at you with another math lesson. It's Friday, so everyone's excited. We're doing 4.6 day 1, and we're going to learn how to solve equations with using logarithms. Okay? Make sure you hit like and comment and subscribe, and hope you're having a happy day. Woo! Oh, I'm halfway to 30 subscribers. I have 15 now. Thank you, Ashley. She subscribed. Okay, so our first few examples, we will be solving for x with an x in an exponent position. Okay? So our strategy on the first few problems will be to get matching bases so that we can set our exponents equal. All right, so in this case, do you see how 3 matches 3? Since 3 matches 3 and both sides of the equations are equal to each other, that forces their exponent to be equal. So I can make the conclusion that 2 must equal 4x minus 6. Does that make sense? Nod your head. Okay, very good. And then it's nothing more than a normal Algebra 1 problem. So let's just add our 6. That'll be an 8. And divide both sides by 4. X equals 2. And you can feel more than free to check your work if you would stick that 2 in the equation up there. It would make the exponent of 2, and so 3 squared would equal 3 squared. Spencer? And do it in your head. So Spencer's just like, oh, I know this must be a 2, so x has to be 2. It works if you can do it on your head. Oh, so not necessarily. What if this had been, let me change this. What if this had been 3 to the 5x plus 8? Do you know what I mean? Then x is not going to be a 2 in that case. 2 would equal 5x plus 8. So I'd subtract the 8 over, get a negative 6, divide by 5 and do adjustment.
Right.
Yeah, the equation still would work. All right, we're going to rework all this Spencer problem. We're going to rework this Spencer's way with the Spencer problem I just created. So I just created a brand new problem. I'm going to set 2 equal to the 5x plus 8, just so I can solve it. Go ahead and subtract 8 from both sides. 2 minus 8 is a negative 6. And then divide both sides by 5. So it's negative 1.2. This equation absolutely would still work. If I put a negative 1.2 into x, 5 times negative 1 is negative 6, and then when I add an 8, I get a 2. So both the x values are 2. Makes sense? Okay, awesome. Let's try another one. This one's a little bit harder because the bases don't match originally. But that's okay. We'll figure it out. Okay, so is there any way I can rewrite one of these sides, or maybe even both of these sides, to make them match each other? That's what you ask yourself. So I'm looking, I saw the 4, and I saw the 1/2, and I'm like, I need these to have matching bases on both sides. I'm like, oh, they have a 2 in common with each other. So I rewrote the 4 as 2 squared. Okay, still had that x out front. What is 2 times x? 2x, that's how I would write the left side. On the right, this is a little bit harder. Do you guys remember flip and make it positive? Remember that? So what would 2 to the negative 1 equal? Flip and make it positive. It would equal 1 over 2 to the first, or 1/2, right? So what I'm going to do is rewrite the 1/2 as 2 to the negative 1, because those are equivalent. I know that's strange. That's the strategy. Okay? Now to kind of clean up this exponent, the negative 1 does unfortunately have to distribute, and it's a bit yucky. It will make it a negative x plus 3. And now I have achieved my goal. My goal was to make my bases match one another so that I can set my exponents equal. Does that make sense? So since 2 to the 2x equals 2 to the negative x plus 3, I conclude that 2x equals negative x plus 3. And you just solve it like a normal Algebra 1 problem. So plus x on both sides gives me 3x equals 3. And divide by 3 on both sides to get x equals 1. You can check if you want to, but that is correct. So that's a hard one. Did you follow what happened? Yeah. I know, that is such a stretch. I wanted the goal of everybody being a base 2, okay? I knew my 4 could be a 2 squared, and I knew the 1/2. I remembered this from back when we worked with negative exponents. If you would have 2 to the negative 1, you'd have to flip it to the bottom and make the exponent a positive. So 2 to the negative 1 actually is equivalent to 1/2. So I just substituted this for this. With the goal of making the bases match.
So you just have to work backwards.
Yeah. Work backwards. Alright, we got a new math problem up here. This one is not nearly as bad as the last one because there's no fractions. We're going to use the same strategy. We're going to try to make those bases match. So think about that 9 and 27. I heard somebody saying 3, 3, 3. You're exactly right. 9, we're going to rewrite as 3 squared. So that'll look like this. How could we rewrite 27? 3 to the 3rd. Awesome. So now I'm just going to clean up my exponents because they look super yucky right now. 2 times 2x is 4x. And 3 times x minus 1 needs a little distributing. It would be 3x minus 3. Now, do you know how to finish it from here? No. We did it on the last two. If you have 3 to a power and you have 3 to a power and they're equal, those powers better be equal. It's called setting the exponents equal. So you set the 4x equal to 3x minus 3. And now who do I want to move? Yeah, I always try to get my x's together first. So I would move my 3x. And x equals negative 3. Awesome. So that's the last one like that, where we're getting our bases matching. We're going to go with a whole new strategy on the next one. Okay. This next strategy, it says when it is not convenient to write each side using the same base, you can solve by taking a logarithm on each side. So no matter how hard we try, I don't think we can get 11 written as a base. We can't make it like 2 squared or 4 to the squared or anything, you know, so we can't make these match. So go ahead and write it in your notebook like this. 4 to the x equals, leave a blank space, and then write the 11. I want you to leave the blank space, because we're going to be putting something there. Any guesses? A logarithm! You guys are smart. You're good at guessing what we're doing next. Okay, so I have to solve for x. I need the 4 to go away. Can I divide by 4? No. Can I? Yeah. No, it doesn't matter that I'm getting decimal. You can't divide by 4 and have x be like a number. That doesn't work. Can you do the 4th root on both sides? That one really moves the 4. The only thing that's going to be able to move the 4 and cancel the 4 is doing a log base 4 on both sides. Okay? Because a log base 4 of 4 has the overall value of 1. And we can cancel it out, and it leaves us with that x. So that's where all that stuff we did this whole week is leading up to this moment where we can solve equation. And we just type that in. And Spencer and Lexi remember how to type it in their way, right? Oh, your calculator is so easy. Math, up, enter. Put the 4 in the little box, put the 11 in the big box. Divide. So the Spencer-Lexi way is log 11 over log 4. Everybody else, you have a special button. You can just do that. Oh, actually, I believe you're on the TI-83 thing. This is the TI-83 way. Ethan? 7 divided by log 4. I'm going to show you my calculator. There's 1.2. Okay. Awesome. Ready for a new one? When you write it in your notebook, leave a big space in front of that 5, because you know what's coming. Who has an idea of how we can get that 2 to cancel? Nick? Log base 2 on both sides. Log base 2. And then we cancel, leaving us with an x, because that has a value of 1. That's why it cancels. And you type that in. Math up button. If you're using a TI 84. Get those buttons rolling. Make sure you know where the buttons are. I think that's why you'll do so much better on your next attempt at the ACT. That's why you take the ACT numerous times.
Yeah.
Did you guys get 2.32?
There's like
All right. This one's getting a little bit harder with the 9x in the exponent, but we're going to use the same overall strategies. Leave that big space when you write math problem down. 2.32. We have all of our phones in our book bag, so we are not utilizing them right now. All right, what do you guys think we should do to cancel that 7? Log with a base of 7. Cancel it. Log with base of 7. We're doing it on both sides to keep our equation balanced. You always have to do everything on both sides. So we won't quite be done after we figure out what log base 7 of 15 is. It's 1.39. That's what 9x equals. So we have one final step. What do you think it is? Very good. 0.15. And if you guys could just round everything to the hundredths for me, it'll be so much easier grading. All right, next. Holy macaroni! What's even going on here? Spencer? Hundredths would be great, so 2 decimal points. I'm not going to count it wrong if you round differently, but it just makes it easier. And then some people like to write down 15 decimal points and like, well, call it. Alright, so this is our first one with the E. That's the first thing that might have caused you to panic a little bit. How do you think you could cancel out an E? So if you have an E here, the best way to cancel an E is an LN button, because an LN button has an E, so that's what we're going to be using. Now there's a whole lot of other stuff here we have to get rid of. You can't take an LN with all this other stuff here. So let's move the 7 first. So do a plus 7 on both sides. That's going to give you a 20 over there. Are you ready for the LN now? Spencer? Good. We want to divide 4 next. That's an awesome idea. That's exactly what I was hoping somebody would say. So that's going to be a 5. You can leave myself a blank spot for that 5. You know it's coming, right? Some sort of log usage. Alright, we're ready to cancel down our E. So the best way to do it, not the only way to do it, but the best way to do it is an LN base E right here. And when you use the LN button in the calculator, it automatically knows the base is E. It has to be a base E. So you just type LN 5. You don't type E. Okay. LN 5. The LN button is beside the 4 button if you've never used it. I had a girl today, it was the first day she'd found the button. Because, you know, some people go through class without ever getting their calculator out. Which is not a good way to go about class, is it? Alright, and then I just hit divided by negative 0.3 to finish off the problem. Negative 5.36. Is that what you guys got? Remember that. Yeah, it's right. Looked in the book. All right, if you can survive that, you can survive anything. We're going to do one more problem and call it a day. Sound good? It's a word problem. I know you're going to say that. It's not bad. Let me know when we're ready. I see some people writing stuff. Good? Okay. All right. Pam invested $400 at 8% compounded continuously. It's been a week or so since we've been talking continuously compounding. Is that formula still on the board? Look up there. Point to the formula we're going to use because there's so many choices. This one! What did you say?
How can you tell that?
Just, I don't know. Only you can tell where you're truly pointing. So we're using this formula first because of that compounding continuous phrase. All right, we have a lot of stuff that needs to go in. Where should I put the 400? P. Yep. Where should I put the 8%? R. And E is just the value E. It's not a variable that you're putting a number in. And where should I put the 1981.21? In for Y, because that's how much she has at the end of the time period. And you know what we're solving for? How much time has gone by. So I'm going to call that X, just because I don't like the variable T. Okay? Yeah, T's look like pluses. They're yucky. All right. What should we do first? Divide by 400 is definitely correct. Divide by 400 on both sides. Gives me 4.95. How can we cancel the E? ln on both sides because ln has a base of E. Now here is a calculator trick I want you to practice. Type ln and then type second negative button. The answer button, that's the answer button, and it'll plop that 4.93025 in there for you. Okay? Do you guys use the answer button a lot? So I did ln second negative key. So it plopped the previous answer in there. And so I didn't have to type output like that. You know? I use that answer key all the time. You get it with second negative key. So that's 1.599, bunch of nines. And then finish it off by dividing. Lost you. Where'd I lose you at? Oh, you're okay? And it's like 19.9999812 years, so just round it to 20 years. Basically, Pam had her money in that account for 20 years. What do you think? Do you love logarithms? Aren't they fun? We didn't have any frogs today, so it wasn't that happy of a lesson. All right, the homework is going to be a worksheet, but we are going to roll the dice early before I pass it out. I know I'm stopping.